Hello everyone, welcome to JCE Connect, subject Operations Research and Module 5, lecture number 5. So in today's lecture, we'll be learning about the graphical solution procedure in the game theory. So far we have discussed about the two-person zero-sum game, then saddle point, then what is dominance method, and what is the mixed strategies for game theory. And today's lecture will be about the graphical solution of those game theories. So moving on, what does the graphical method do? It helps us in finding out which of the two strategies can be used. So suppose that a player in a game has two strategies, case A and case B. So which strategy has to be used for the player A can be determined using graphical method. The strategy which can be best suitable for him. The graphical method gives us that solution, whether case A or strategy A is better or B is better. So here we have two cases, that is m into 2, that is m by 2, and 2 by n. So earlier we have seen the problems based on 2 by 2 matrix or n by n matrix, right? M by n matrix. So here we'll have two cases wherein we have m by 2 and 2 by n matrix. So m by 2 is the minimax and 2 by n is the maximum approach. Okay, so basically in a graphical solution, when we have this 2 by n game and no saddle point. So here in the matrix you can see that player A with two strategies, player A has two strategies, and we have to define whether graphical solution, which solution will be better, which strategy will be better rather, strategy 1 or strategy 2, but how to determine, and that's how our graphical solution is going to help us. So we have two strategies for player A and 1 to n strategies for player B, right? So here is what a matrix look like, just a simple combination. So when we say that let x1 and x2 be the probabilities, we know that the x1 plus x2, the probability of both two strategies will be 1, right? So let x1 and x2 becomes 1 minus x1, okay? So let x1 and x2 be the probabilities by which a player A selects first strategy and second strategy respectively. Okay. So let us see how it is done. Like B's pure strategy, A's expected payoff is 1, right, which is from the matrix you can see, and from A11 so on up till n. Okay, this is slightly this is slightly disformatted. Here it is 1, just a moment. Yeah, here it is 1, 2 and so on up till n. And here we have the expression, that is this expression here. That is the expected payoff, and this one here, right? And for n value, this is the expected payoff. Okay, so I'll modify this, I'll edit this file, and I'll post a picture of this, the exact picture of this slide in the WhatsApp group. Okay, so fine. Yeah, now player A should select the volume of x1 that maximizes his or her minimum expected payoff, right? The player A has to select the value of x1 in such a way that it maximizes his or her minimum expected payoff. Please read this line carefully. Okay, he has to maximize the minimum expected payoff. Okay, so let us understand this with an example. Consider we have a game of a payoff matrix. We have two strategies for player A, A1 and A2, and we have, let's say, 5. So at n is 5 now. We were talking about 2 by n matrix, right? 2 by n. By m matrix. So here m is 5. Okay, so we have 2 by m, two strategies for player A, two strategies for player A and 5 strategies for player B, but we have to select whether which of the two strategies for player A, that is A1, strategy A1 or strategy A2, which among these two strategies is better. So graphical solution helps us to find out which one is better. Now the solution, look at the solution. First step is to apply dominance rule. Dominance rule, we can cut out the, why? Because we can cut out the unnecessary columns. We can cut out the columns which are not leading to the solution, which are likely to not to lead to the solution, and we are only going to keep the columns or process the columns which are probable can lead to the solution. Okay, so we have to first apply the dominance rule. Now how to apply the dominance rule? Let me quickly recall back the dominance rule that we have learned, which is the strategy. It is the strategy of a player dominates over the other strategy in all condition. The latter strategy can be ignored, right? So the dominance method states that if the strategy of a player dominates over the other strategy in all conditions, the later strategy is ignored. Okay, so what is the rule to apply for dominance method? Rule number 1 is to, if all the elements in a row of a payoff matrix are less than or equal to, right? So please note here, if all the elements, first of all the elements in a row of a payoff matrix are less than or equal to, please note here, less than or equal to the corresponding element of other row, then comparative row will be deleted, right? So we don't require that row because it is nowhere leading us to the solution. That is, if all the elements in a row, please read the rule number 1 again. If all the elements in a row of a payoff matrix are less than or equal to the corresponding elements of other row, then comparative row, the row which we are comparing, the comparative row will be deleted. And the rule number 2 says same, if all the elements in a column in a payoff matrix are greater than or equal to, right, greater than or equal to the corresponding elements of other column, then the comparative column will be deleted, right? The comparative column, the column which we are comparing to the other columns, that column will be deleted if all the matrix of the column in a payoff matrix are greater than or equal to, right? So I hope you have understood this. So let's move on. That is this. Okay. Let me clear this off so that the thing is clear to you. Now solution. Like we discussed, this is the dominance rule, and for rule 1, elements less than or equal to, the row with the elements less than or equal to will be deleted, and in rule 2 says column in the payoff matrix with the elements greater than or equal to will be deleted, right? So let's see how it is done. Now when we apply this dominance rule here, you can see, let us consider column number B2. The column B2 is, when you compare row wise, that is the rule number 1 says that all the element of the matrix, payoff matrix is greater than or equal, less than or equal to, then the corresponding element of the row then will be deleted, right? So minus 4, you can see here, minus 4 is less than the all the other elements in that particular row, right? So that will be deleted. And in the rule number 2 says if all the elements in a column in a payoff matrix are greater than or equal to the corresponding, then the column will be deleted. So here you can see 4 is the maximum value in that particular column, right? 4 is the maximum value, so that this column will be deleted, and so on. So here you can see minus 4 is the minimum value in this row, and 6 is the maximum value in this column, so this will be deleted. 0 is the minimum, 5 is the maximum value in this particular row, and this column is also then deleted, right? So we have deleted 3 of the columns, and only B1 and B4 remains, right? Only B1 and B4 remains. So we have to process only, or we have to plot the graph only with respect to column B1 and B4 with strategy A1 and A2. How? Let's see this. So this is the updated payoff matrix now that we have, and this is how we are going to plot the table. We are going to draw the lines integer wise, that is negative minus 5 to 8 and minus 5 to 8. This also 8 is just for the consideration that it may, the points, the maximum value that we have in the payoff matrix is 6, so you can take till 6 also, fine. So maximum is 6, minimum is minus 4. So we'll plot a graph, let's say minus 5 to 8, okay, and we'll plot all the points which are given in our original payoff matrix here in the graph, okay. So once we know that we have plotted, for example, let's say this particular B1 column, right, B1 where A1 is 2, A2 is minus 3, right. So A1 is 2 and A2 is minus 3. So this is our line, first column. Second, minus 4, B2 column, minus 4 plus 4, sorry. We have in B2 column, we have minus 4 for A1 strategy, and we have value 4 for A2 strategy in column B2. So let us plot that, minus 4 and 4. So this is minus 4 and 4, okay. Next is B3 column, maximum value, that is 6 for A1, and A2 is minus 4. So A1 6, this one 6, and A2 is minus 4. So this line. Then we have minus 3 and 1, B4 column, A1 strategy minus 3, A2 strategy 1. So A1 strategy minus 3, A2 strategy 1. This is the line. And the final column B5, A1 strategy 5, A2 strategy 0, A2 strategy value 0. So 5 and A2 strategy 0. So this is the line. So once we have plotted all the 5 lines, let us now consider our reduced matrix, right. We have deleted 3 columns and we have reduced the matrix. So this is our current matrix. So according to current matrix, only 2 lines will be considered, right. That is B1 for B1 and B4 columns, A1 strategy 2, A2 strategy minus 3. That is this line. A1 strategy 2, A2 strategy minus 3. So this line. And then we have minus 3 and 1. This is minus 3 and 1. So this line. And you can see here that the intersection of these 2 lines, this line will be our solution, right? This will give us the solution. Now let's see how. Now after applying the ornament method for the matrix, we conclude that the value of the game will be 2 into 4 by 9 and minus 3 into 5 by 9, right? That is 2 into 4 by 9 and minus 3 into 5 by 9, right? So according to the value of the game, we have to add those values leading to the solution. So once we find the value of the game, that is 2 multiplied by 4 by 9, which is plus the again value, but here the value is minus 3, so we'll have minus sign here, minus 3 into 5 by 9, and the value of the game becomes, once you compute this, the value of the game that we get is 7 by 9. Okay, so this becomes our solution for the graphical method. Now this clears that the strategy that has to be used by the player A, which is the strategy A1, right? Okay, now there are a few of limitations to this game theory as well. It doesn't fit everywhere. Not all the problems with respect to operations research can be solved using the game theory because of the limitations that the game theory has. Now what are those limitations? The assumptions that each player has the knowledge about his own payoff and payoffs of the opponent is not practical, right? I hope you get this. The assumptions that each player has the knowledge about his own payoff and payoff of the opponent is not practical. So sometimes there will be few problems, few games wherein the player will be not aware or not knowledgeable about his own payoff or the payoffs of the opponent, right? So that if that is the case, then the game theory will not be able to give you the solution. The second limitation is the method of solution becomes complex with the increase in the number of players. You must have experienced this in our previous examples when we solve. If you go on considering more number of players, the level of complexity, the number of processing, number of steps involved becomes more high, right? The number increases. So that is one limitation of the game theory, that the method of solution becomes complex with the increase in the number of players, right? And the third limitation in the game theory is that it is assumed that both the players are equally wise, right? You must have observed this also in our previous example, that in all the examples it was necessary to know, or it is mandatory to understand that both the players are assuming that both are equally wise, right? But if the scenario is different, that one player is not wise and one player is very clever or wise, then of course, even though if for example, let's say player A is wiser than player B, but player B has a very good upper hand in the game and has very good strategy to play available, but since it is not wise, that strategy will not lead to the optimal solution. So in that case, even though player B was was more in a position to win the game, but didn't win the game because it was not equally wise as player A, right? So that is the third limitation, that the game theory assumes that the both player are equally wise, which will not be the case practically sometimes. Okay, in the game theory it is assumed that both the players are equally wise and they behave in a rational way. This assumption is also not possible because it is not practical, right? So these are the few of the limitations of game theory. Hope so you have understood it. If at all you have any query, anything, you can post it in the group and or comment down in the section down below, so that whatever doubts are there will be addressed to everyone. And practice more such questions. Just go through the solved examples in the test books also, so that you have a grasp or the hand grip on the exact concept of game theory. So this brings us to the end of the game theory chapter, that is the first part of our module 5. And from the next lecture onwards, we'll be starting off with the second part of module 5, that is meta heuristics. So before we move on to the meta heuristics, I would like you to go through all the solved examples or exercise questions in the test book given. And if you have any doubts, any queries if you want to ask, you can ask me anytime. Okay, so that's all for today's lecture. Thank you.